Okay, we are now recording. So thank you again for joining. Many of you I know and have spoken to, so hopefully this will be informative and possibly review for some. Securing your remote workers, as Elaine said, we're getting a lot of questions from the field about how do I protect my remote users now that we suddenly have hundreds of employees needing to connect back to their corporate resources in some way. So we wanted to give you some of the tools and tips and tricks and things that you can do to better enable your remote workforce. So we'll have a quick overview of who WatchGuard is and what we do, and then we'll go into securing remote access, what kind of tools are available to you, securing your user accounts, and then finally the endpoints themselves. Again, this is meant to be interactive. If you have questions, please put them in the chat. I'll try to answer them as we go along and leave some time at the end for Q&A as well. So first, about WatchGuard, if you don't know us, we were founded in 1996. We have over 700 employees headquartered in Seattle, Washington, with offices and sites across the world. Several 80,000 plus customers and 100 plus distributors, thousands of active VARs. We have three different pillars of our technology: secure Wi-Fi, multi-factor authentication, and of course, network security, the unified threat management firewalls that we all know and love. WatchGuard has been an NSS Labs recommended UTM device for several years in a row. We consistently score well on their tests for 100% blocks of evasive techniques, excuse me, for breaches and malware. Especially when compared against the cost of some of the larger devices like a Palo Alto Networks. So we really want to bring you the best of class security at a reasonable cost. So that said, securing remote access. Let's talk about VPNs. When we talk about VPNs, there are really two different primary classes of VPN that we discuss. Branch office VPNs, which are also often called site-to-site VPNs by other vendors, which are used to connect two locations together between two firewalls. Typically, we're talking fireboxes, of course, in the WatchGuard world, but this could be a third-party firewall, right? So a Cisco or a SonicWall or something like that. Even some consumer-grade firewalls that you might find in a Comcast home modem or something like that could potentially be able to connect to a WatchGuard device. And then the primary one that we get the questions about are, of course, mobile user VPN. So this is the VPN software that you have running on your machine. It may look something like this right here. That's used to connect your remote workforce via their PC, their desktop, their laptop, their phone, their tablet, whatever, back to your home office. Now, of course, when we do this, you suddenly have anywhere from 1 to 5 to 10,000 plus users all connecting to your home office, which is why we're suddenly seeing a lot of questions about this, because previously you may have only had 5 administrative users who need to get back in and manage servers back in the data center. Now we have hundreds or thousands of users who are stuck at home. So now that we've classified the two different buckets, basically, of VPN types, branch office versus mobile user, there are different selections of VPNs underneath those types that have different qualities that you want to bear in mind when you're trying to build your VPN remote access solution. So first of all, you can go with the bottom point first. Branch office VPNs are typically IPSec IPv1, or we do support TLS VPNs for third-party devices. pfSense is a popular one that uses TLS. So the 4 types of mobile VPNs that we're going to talk about are IPv2, L2TP, SSL, and IPSec. And we're actually not doing them in that order. We're going to do them in order of their popularity. So first, IPv2. IPv2 is the newest, strongest, and fastest of the VPN types that are supported. This is supported on native OS clients. So your built-in VPN client for Windows, Mac, iOS, Android, Linux devices, basically any modern operating system on a device is going to support IPv2. It has extremely high security, it is very fast, and it has some capabilities built in for fast network switching and resiliency. So if your network is very jitter prone or has a lot of latency, it's really designed to reconnect your users without interrupting the tunnel. So it's a very, very powerful VPN. Now, with that, there are a couple of downsides. Number one, you can only use the built-in Firebox authentication or radius authentication for authenticating your users. There is a workaround for that. If you want to use Active Directory group synchronization, there's something on AD called NPS, Network Policy Server. It's a free plugin on Windows that actually builds a radius server on your Active Directory domain controller. And you can actually plug your IPv2 VPN into NPS and then use that to manage your AD group membership and user membership. Another con is that some older firewalls that you may encounter in some locations, older ISP firewalls that are built into your home router, or if you're at a hotel, for example, sometimes they'll actually block IPv2 traffic. The next most popular after that, and you saw me drag that over, is the SSL VPN, which is actually technically a TLS VPN. Again, it is supported by most native OS clients in the modern world, or the free WatchGuard client that you can download from watchguard.com or directly from the Firebox. Because it is SSL TLS, it can bypass most firewalls and ISP restrictions. It's using HTTPS, basically, port 443. It does allow for split tunnels. So when we talk about tunneling, IPv2, all traffic is sent over the VPN back to the home office, and then it hairpins back out of the home office to the internet. This does mean that your users who are sitting at home browsing YouTube or watching Netflix are now sending that traffic back out of your home ISP connection, or your home office, ISP connection, which can incur a lot of additional network overhead to your internet pipe. So SSL VPNs get around that by allowing for splitting that tunnel. So the users who are sitting at home, their internet traffic goes to the internet and their VPN traffic goes to the VPN. That reduces the network load at your headquarters, but it is actually a little less secure than a full tunnel, but it's there if you need it. It does also allow for native authentication with Active Directory without having to use an NPS server. Now, cons. It is slower than IPv2. It is not as secure as IPv2, and it is pretty sensitive to latency, jitter, and loss. So if your users are sitting at home and they have a somewhat dodgy internet connection, they may experience slowdowns or drops while the tunnel tries to renegotiate. This is just, unfortunately, a factor of SSL VPNs. Next is the IPSec VPN, which is actually an IPv1 VPN, technically. All of these, we're not going to go too far into encapsulation technologies and encryption technologies and hashing algorithms, but all of these technically use IPSec in some way, except for the SSL VPN. But when we talk about IPSec VPNs, we're saying IPv1, basically. IPv1 VPNs have some support in native OS clients. It's not as extensive as IPv2 or SSL VPNs. And we do have a paid WatchGuard client that you can use for that. It's really good when you do need to do some complex routing based on groups. So for example, if you have a single VPN concentrator with different companies that are connecting to it, you can have different routing profiles based on their group membership so that you can route their traffic to different headquarters offices. So that's very flexible, but it is slower and less secure than IPv2. And again, because it is based on IPsec, it may be blocked at the ISP level. And then finally, we have L2TP, technically L2TP version 2. This is really built for legacy clients. So if you still have devices out there that are, say Windows XP or something like that, it's really designed to support those. It's an older VPN type. It is not as fast or secure as the IPSec IPv1 or V2 VPNs. It does use IPsec, but that can be disabled to get around ISPs blocking it, but that makes it even less secure. And that also allows for split tunnels. No questions about that? VPN Basics. Okay. So the next question that I get pretty frequently, how many VPN connections do I have or do I need or can I get? So in the old days, XTM devices were often sold with a base number of VPN connections. You'd get 5 when you purchased the device, and then you would have to license up additional connections after that. We don't do that anymore. Every device that we sell is sold with the maximum number of VPN licenses that the device will support. So to find out how many that is, in a pre-purchase environment, you can look at the product comparison tool on our website. We have an appliance sizing tool where you can go and enter how many users you expect to have and how fast you need the device to be, and it will build a suggestion for you. We have data sheets for all of our devices with in-depth specifications. And then if you already have a device, you can very easily go and look at your feature keys and see how many VPN seats are included with that device. And you'll see here, let me get my little highlight tool. You'll see down at the bottom of this VPN tunnels right here. Now, one quick note about this. When we list the VPN tunnels, SSL and IPSec are listed as 2 different line items. That's because they use 2 different engines under the hood. Now, when you look at this, these numbers say, for example, for the T35, T55, 50 SSL and 50 IPSec. You could potentially have 100 users connecting to a T55, but that is probably going to be more than the device itself can handle on the outbound. So really, when you're looking at these, you want to choose one of these numbers and not try to add them together. It's technically supported to do both at the same time, and you could, in a pinch, have 100 people connecting to this single device, but it's really going to struggle under that load. So bear that in mind when you're looking at these VPN numbers. You want to basically choose one. Don't try to add them together unless you absolutely have to, just to get by for a few days. So a quick comparison chart. One of the things we're going to talk about here are Firebox V and Firebox Cloud. These are virtual Firebox devices, virtual firewalls that can be hosted either in your network or somewhere in a cloud resource. And a quick mapping here that shows you the recommended users, which usually is going to be very, very close to the licensed VPN count. One difference here is on the Firebox Medium for the Cloud and V, these are actually licensed for 600 VPN connections. So very, very powerful, tons and tons of users available to you. So why would we want to go with a virtual device, either Firebox V or Firebox Cloud? Well, if you have a Firebox back in the home office that may be struggling under the load, what you can do is reduce the overhead on that device by actually offloading your traffic from the headquarters VPN to a cloud resource. So instead of having 200 connections coming back to the home office, you now have 200 connections coming back to somewhere in the cloud and a single connection coming back to the home office. So this can be a way to get around licensing constraints on the device itself, on the physical device itself, as well as offloading some of the overhead that it may incur by handling all of those tunnel buildup and teardowns. Questions? None yet. Okay. Moving on. So Firebox V. This is available for Hyper-V, VMware, or coming soon in the next couple of months. It was supposed to come out in a few weeks, but with the coronavirus stuff, some of our releases are being delayed, and 12.6 will support KVM on Linux. So this is very easy to deploy. It does require you to have some hardware in your network or hosted somewhere, physical hardware or Hyper-V or virtual Hyper-V works, that you install onto. So it requires a hypervisor. It's very easy to take one of these and actually upgrade it to a larger model as needed just by changing the feature key, which is a great feature. If you have one that's a Firebox V small and suddenly you say, I've got a bunch more VPN users, I need a medium, You can contact us, get a license for a medium, and upgrade in place. Unlike our physical devices, there is no crypto assist chip, so we actually have a specialized ASIC in our fireboxes to handle VPNs. Obviously, when you're talking a virtual environment, that physical ASIC, that chip is not going to be there. So the VPNs, although you get a lot of them, will not perform under the hood as well as they would on a physical device. So you need to make sure that you assign enough resources, CPU and RAM and disk, to the device to support the number of users you need. Firebox Cloud, on the other hand, unlike V, which requires physical hardware or a hypervisor of some kind, Firebox Cloud deploys directly in the AWS or Azure marketplace. So you can go right into your Azure account and browse through all the available appliances, and instead of building a Windows machine with Hyper-V on it, you can say, give me a WatchGuard Firebox. There are two different license types available for that, pay-as-you-go or bring your own license. Pay-as-you-go only charges you based on the amount of time the device is up and running. Bring your own license is simply a feature key, a license that you apply to an existing resource in Azure. So one catch there, if you go with the pay-as-you-go, you do not get some of the features that you would get in the full Firebox, such as DNSWatch and TDR, which we're going to talk about later in this presentation. Again, there's no crypto assist chip, being a virtual firewall, and you have to actually give it enough resources to perform up to the level that you expect. Another common question is, what security appliance subscription do I need to use a VPN? So again, back in the old days, we had a lot of different subscriptions. We've simplified our licensing model. So now any device, any Firebox that has a valid support agreement has VPNs available to it and the maximum number of VPNs that that device will support. Some of the features that we'll talk about in a moment here are only available in the larger package of Total Security Suite, specifically Access Portal, DNSWatch, and TDR. So what is Access Portal? This is available on the M series and virtual devices, and it is a clientless browser-based HTML5 web page that the Firebox hosts that allows you to export out internal applications or tie in cloud-based single sign-on applications like Office 365, Box.com, Salesforce, etc., or host internal web servers in a secure web page. So this allows you to put everything in one place without desktop software or client that your users need to log into, and they just log into the Firebox. It's a customizable page, so you can brand it for your own company. It, of course, supports multi-factor authentication, but it is somewhat resource intensive, which is why it's only available on the larger devices. It uses up to 100 megabytes of RAM per session, especially when we're talking about hosting terminal server sessions in this interface. Okay, no questions yet. This is going very fast. All right, so that's the basics on VPN and remote access technologies, how to build the tunnel, how to get the pipe back to headquarters. Now, what about user accounts? Excuse me, I just knocked my headset a bit. So, of course, now remote work is suddenly becoming the new normal. This is what everyone is doing. And of course, with that, that means that attackers are targeting our accounts even more so than they were doing before. So your VPN is protecting the traffic back to your headquarters resources, but what about the logins themselves? It really isn't very difficult if I have someone's login information to guess what the VPN they're going to connect to is going to be, or to do some port probing and start trying to randomly connect to things until something answers. There are sites out there, dark web scanner type of sites like Have I Been Pwned, that will show you there are millions of breaches, billions of leaked accounts, excuse me, where our user accounts, all of us, have had our user accounts exposed at some point out on the internet. The lack of password complexity and password reuse means that if somebody is able to get one of these lists, there's a fair chance that they may actually have the passwords, usernames and passwords to your corporate resources. And of course, with cloud-based being such a popular thing, everybody's moving to Office 365 and cloud-based resources. SaaS, software as a service, is a growing target. It's up over 200% in the last couple of years. 36% of attacks against accounts in Q2 of 2019 were against SaaS resources. So that's the largest single attack vector. So how do I protect this? Well, you use 2FA or MFA. This is what we all need to be doing today. It's something you have, something you know, your username and password, and something you are. 2 or more of these factors. There are solutions out there that use SMS messaging, text messaging, or email. These are terrible solutions. I have a couple of sites that I log into that still use them. They're really not a good solution for 2FA because they can be very easily spoofed with phone cloning, SIM swapping, email rerouting, things like that. It's just very, very easy to redirect that 2FA message to someone else. So what you really want are time-ordered event-based tokens. There are also tokens out there by some vendors, I'm not going to call anyone out, that are event-based only. They're much more convenient to use than the time-ordered tokens because they don't expire, but they're not as secure because they don't expire. They're subject to replay attacks. So an event-based token, if somebody looks over your shoulder and writes it down, or gains access to your device for a brief period of time, tries to log in, copies that number, and then gives you the device back, they can actually replay that token. So you want something that expires. And then finally, there are now some popular hardware keys that are being generated out there. A USB key, for example, or Bluetooth key, where you just need to be near your device. So those are very convenient, but they can be stolen. So a combination of 2 or more factors. All it takes is one bad user with one bad password, or a keylogger, or someone who shares that OTP or shares their device. So again, you need multiple layers of security and multiple factors to mitigate against this. So how does WatchGuard help? Well, of course, we do have multi-factor authentication. We can control access to your assets, accounts, and information. It's a very easy mobile phone application. And even if your user's passwords are stolen, with that multi-factor authentication, they're still protected. The different layers basically of the solution is, of course, the technology itself, multi-factor authentication, supporting the password as one factor, and then push, biometrics, and phone DNA as additional factors to authenticate the device. The app itself is available for iOS and Android. Everything is driven through WatchGuard Cloud, and we have many, many different integration guides and different tools of providing different resources for your logins. You can protect VPNs, you can protect third-party web apps, cloud-based applications, you can protect desktop logons. We also have APIs available if you want to write your own connection. We protect terminal servers, and right now we are offering free 250 user license seats for up to 120 days for AuthPoint. Again, some quick bullet points here. Cloud-based management, all of your configuration reporting and software downloads are done via WatchGuard Cloud. You don't need to know any scripting. It's not a very complex technology to roll out. The user adoption is very easy because the users can use their device that they're familiar with, their Apple or Android device, and go and download the authenticator from the App Store. We actually also support third-party applications. So if they want to use the WatchGuard app, it's freely available to them to use for something like their bank or Facebook or LinkedIn. It allows for different types of authentication methods. Push notifications, which are very, very handy. The user doesn't have to type anything in or even pull their phone out of their pocket if they have a smartwatch. It just pops up a message saying, are you trying to log in? Yes or no. And then if they're offline, if their phone doesn't have connectivity, but they still need to log into a desktop or something like that, we have QR codes and time-based one-time passcodes so that it will work anywhere. One of the questions I frequently get is how many tokens can a single user have? Well, a single user can have many different tokens. They can have a different token for every resource they need to access. They can also have different devices with different tokens. So they can have a phone and a backup phone, or a phone and an iPad, or if you have, I hate to say shared accounts, but if for some reason you have administrators who are sharing accounts, those two different administrators can share the same token and log into that same account without having to swap the device back and forth. The devices themselves are fingerprinted with mobile DNA, so several different types of checks that we do to ensure that the device hasn't been cloned or there isn't some kind of SIM swapping going on where someone is trying to spoof the mobile device itself. We do, of course, support PINs, which I'll show you in a moment, and biometric protection. So users can use Face ID or fingerprint scanner on the device. All of the licensing in AuthPoint is per user. So when you go and you roll it out, if initially you only want to protect VPNs, you license all of your users, and then later you say, wow, I really like the identity provider portal, or I also want to deploy the desktop login application. How do I go about licensing that? There's no additional licensing. Your user is your user. It's already licensed. You just add the additional resources that you want to protect. And again, many different types of resources that we protect. We're adding more constantly. So we have a desktop logon application I'll show you in a moment, VPN sessions, remote desktop sessions, cloud-based resources. We do support Active Directory synchronization, so you can manage your users and groups in the cloud with a connector that reads from your directory. And that's a small piece of software that sits within your network, so we're not sending passwords back and forth. No questions yet, quiet group. Okay, so let's do some demo stuff here. So I have a little piece of software called A Power Mirror. This is actually my phone. And you will see when I open up AuthPoint, the screen turns black. That's because we have actually some token security on the phone itself that prevents screenshots. So this is to try to stop somebody from quickly screenshotting the phone and then before the token expires running off and using that token somewhere else. So I have to unlock this. I'm going to unlock it with biometrics and say allow screenshots. There we go. This is what the app looks like. You can see I have many different tokens in here. Charger. For different resources that I log into, my corporate logins, different demos that I do, my Mac, etc., as well as some third-party tokens in here like Facebook. So I'm going to pull my Mac over here. This will be a little slow because I'm using VNC to connect to my MacBook, and it's not the fastest of screen sharing software. But I will try to log in. And as soon as it wakes up, enter my password, and it pops up the AuthPoint logon screen. This application will look the same whether you're on Windows or Mac. And you see I have my different sign-in options. Because all of my devices are online right now, I'm going to use the push notification, which is the easiest and the most secure. But if I were offline right now, I could use a QR code or the one-time passcode. Or if I had lost my phone, I can hit the forgot token link, contact my IT staff, and they can issue me a temporary passcode to log in. So I'll say send push, and it pops up and says, am I trying to log in, deny, or approve? So if you train your users to watch for this notification and deny requests if they are not logging in, that's logged, of course. So you can go into the cloud and see very quickly if somebody is denying a lot of requests, you know their account has been compromised and they need to go and change their password. So there we go. That's it, the login application. One of the other things I like to show off a bit is the IDP portal, the Identity Provider Portal. So I'll actually show you my real WatchGuard portal because it has a lot of applications in it. My demo lab only has 2 apps in it. It's not very interesting, but this is a lot more fun. So this is a web page that I go to. I don't need any client. I don't need any additional software other than the mobile phone application. And I say send push. Am I trying to log in? Approve. And it opens up a web page with all of the applications that my IT staff have assigned to me. This is not everything that we support. This is just what's been assigned to me. And it's a single sign-on page. So if I go click on Office 365, it just opens up the Office 365 login page. And of course, Microsoft hates Chrome, so do you want to stay signed in? I don't have to re-enter my password every time. And same thing for all applications. I can simply click into the application and it's a single sign-on page that redirects me because I'm already authenticated. It signs into my various applications. Clearly, I'm not going to be doing any travel this week. And again, there are other different types of resources that you can protect, such as terminal servers, either with the desktop logon app or with an RD web connector if you're running Microsoft RD web. There's third-party connectors and integration guides for dozens of different things. If anything supports SAML, chances are very, very good we will support it, whether we have an integration guide written or not. Okay, quiet group, no questions. So let's talk about the endpoints. Now, we've started with authenticating the people. So we've handled the protecting your users' accounts and passwords, but what do we do about the machines themselves? What about the users doing something foolish? Let's talk about DNSWatch and DNSWatch Go. So you'll hear these terms, they're semi-interchangeable, DNSWatch and DNSWatch Go. The difference is DNSWatch is on a firewall on the Firebox itself. DNSWatch Go is a piece of client software that is on the remote device, the laptop, basically, that the user can take anywhere. DNSWatch Go provides off-network protection, so the same kind of protection that you're going to get on the firewall travels with the user. And we'll talk about that in just a second here. Block phishing attempts, keep them safe on the web, as well as gaining visibility into what your users are doing. It does not require a VPN back to the home office. If you're just using the Firebox DNSWatch, your VPN users will be protected. If you have DNSWatch Go, it'll work on or off the VPN. And that does work whether they're connected to a Firebox, whether they're not connected to a firewall at all. They could be going through their phone's hotspot, it'll still work. So how does it work? When a user clicks a link or opens something or visits a web page, the first thing that happens typically is a DNS request. So rather than typing in a set of IP address numbers to go to a site, the user is usually going to enter a name, google.com, yahoo.com, microsoft.com. And the computer has to go out and discover what the resolution of that name is. What address should I go to? That's DNS. So what we do is we intercept that DNS request and we send it to our resolvers and we check it and we say, is this a valid domain? Is it a safe domain? And is it something that the company allows? If it is yes, we let the user through normally. If not, we actually block it. And rather than just having a generic block page that says, hey, you can't go here, we have a block page that is customizable by you as the company owner. And it has an embedded security awareness video session in it that has a 5-minute training session about what the dangers of phishing and misclicks may be. Again, this is available, same thing, same engine, same technology in the Total Security Suite with DNSWatch or separately with DNSWatch Go. DNSWatch Go is a simple client you download from WatchGuard Cloud. You can define your content filter policies. It works with a VPN, and like AuthPoint, we're currently offering a free 120-day license for up to 250 users. So contact me after if you would like more information about that. With DNSWatch, in addition to getting phishing protection, you also get content filtering protection, because we're now seeing those domain name requests. We can look at a policy that you define for your company and say, hey, you know what, you're not allowed to browse alcohol related content when you're using a work resource. So a work laptop, you can't go to a gambling website, sorry. Same thing if you're behind a protected firebox or a protected network. We're not going to allow you to go out, whatever it may be. You can't watch YouTube at work. This is also really great if you want to enforce safe search. So typically, when you're trying to intercept and enforce safe search on Google or Bing or Yahoo or DuckDuckGo, in the network world, you have to usually intercept and decrypt the HTTPS request that's going out to the website, which is how a lot of these services get around content filtering. This happens a lot in schools, of course. But with DNS, now we're intercepting the request before it even hits any kind of encryption. There's no decryption required. We just automatically redirect them back to the safe search page. And there are different policies that you can set at the network level for different fireboxes or protected networks, which are technically separate. You can actually technically use DNSWatch without a firebox. You can contact me for more details. Protected firebox networks, you can have different policies for different companies. And then you have a client policy that is your mobile clients, all the DNSWatch Go clients.
And John, we do have a question.
Okay.
How do you prevent end users from removing DNSWatch Go?
Yeah, so it does require administrative privileges to install or remove the software. It does not allow you to unload the filter or anything like that. So if you're using any kind of a group policy, or if hopefully your users don't have full administrative privileges to their devices, if they do, they could potentially go and remove it. We will be adding some tamper prevention to the product in the near future. Currently, it just requires administrative privileges. But I know I had one customer ask me, a normal user who has not even super user privileges can technically go and unload drivers from the network. How do I prevent them from blocking that? Well, that's already blocked. They can't unload the driver, but they could potentially, with admin privileges, or if they boot into safe mode, possibly uninstall the software entirely. So that's something that you need to bear in mind as you're giving them permissions or building your group policies if you're using group policy objects. Okay, so what DNSWatch and DNSWatch Go primarily help you with is blocking those phishing attacks. So 90% of malware is entering the network through phishing. Somebody gets an email, it says, hey, here's that document you requested, click here. Hello, I'm a Nigerian prince, you've won the lottery, whatever it may be. And that is just, it's a very common phishing, spear phishing, whaling attacks as they go up the chain. We get it at WatchGuard all the time still. Where people send things and it looks like it's from our CEO, and it has an embedded link that says, hey, I'm taking a poll, click here, enter your information, and no, it's not actually from the CEO. So DNSWatch and DNSWatch Go will block those requests and say, hey, this is a phishing attempt, here's what that means, here's how you protect yourself. And unfortunately, some people never learn, right? Even though you tell them, you educate them, they get that security awareness block page, they'll still do it. So you need protection, protect them against themselves. There are malware variants out there that don't even require a download. They're just embedded in JavaScript in the web page. Well, as they try to call out to the command and control sites to download or execute that malware, DNSWatch can actually block that request. Go, as I mentioned earlier, works on or off the network. So it'll work with or without a Firebox, works with a traveling user as they're, well, right now not traveling, but once Starbucks opens up again for their in-dining experience or hotels or something like that, it'll work wherever they are. It does have that embedded security awareness training. The application itself is very lightweight. There's no configuration that you need to do as an administrator to deploy it other than installing it on the client. And as I mentioned, you may want to make sure it's locked down so only administrative users from a certain group can uninstall it. That content filtering is a click in the web interface. You don't have to do any additional installation of certificates on the end user's machine or anything like that. You just define what content filtering policies you may or may not want or enforce safe search just by going into the web interface and applying it to the policy for the devices you want to manage. And of course, we have lots of management and reporting functions in the cloud. And Elaine, I didn't see the question pop up in the chat. Oh, there it is. Now I see it. Okay. If you could just keep an eye on that for me, I'd appreciate it. Thank you.
Yes, will do.
Okay, so we've talked about securing the user accounts. We've talked about protecting them from phishing and misclicks and things like that with DNSWatch Go. Now, there are other ways that malware gets into your network and other things that may happen. So let's talk about endpoint protection with threat detection and response. Endpoint security ideally will block command and control connections, prevent ransomware and the encryption of all your files, kill any in-place malware, and isolate an infected host off the network. Sure, people are sitting at home, but once they connect to a VPN, they are basically in your network, and malware can potentially traverse a VPN tunnel and infect other remote endpoints or just all of your machines back at headquarters. This is a very busy slide, but a quick overview of what TDR is. We have in the cloud threat intelligence called ThreatSync. There's a piece of software that sits on the workstation, whether it's a laptop, Mac, Windows, terminal server, Linux host, physical server, virtual server, VMware or Citrix VDI environment. All of those are supported. That endpoint software communicates with the cloud, and when suspicious files hit the endpoint, there are a variety of policies and functions that can be set up to prevent malware from executing. This does work on or off the network. Oops, skipped over a slide there. All of the reporting and the downloads are from our cloud interface. The policies that you configure are done in the cloud, and there are tons of informative data points that you can pull back about your endpoints and see if something is potentially infected and set automatic policies to prevent those infections. TDR utilizes a lot of different types of detection and remediation functions. So we do have signatures. Those are the cornerstone of any anti-malware solution. This will be a static list of known malware that we can catch very, very quickly. That's fine and all, but most of the problems that we see are in zero-day variants, new malware that may not have a signature written against it. And that's where the other stuff comes in that we need to look at. Heuristics, what kind of algorithms or rules or commands or different attributes of a particular file, process, or network connection make it either benign or malicious. Behavior analysis. What is it actually doing when the file executes? Is it trying to make many copies of itself? Is it trying to go and scan the registry or scan the file system? These are some of the hundreds of different behaviors that we look at. Network detection. What is the network connection on the device itself and on the Firebox doing? How is the traffic flowing out of that device? These are potential data points that the AI leverages to look at potentially malicious behavior. If we have something that's an unknown, a zero-day threat, a file that we've never seen before, we can actually sandbox it from the host, send it up to our cloud sandboxing service, and it will execute this file and send back a score saying that something is either okay or it's bad. If we determine that a host is infected, we isolate that machine with host containment. So we lock it off the network so that it can only communicate with the TDR cloud, and we send back the commands to remediate that. Again, I keep saying with TDR cloud and send back commands, TDR does work offline as well. So if somebody's sitting completely disconnected, they're not connected to Wi-Fi, they grab a USB stick that they found laying on the street somewhere, they plug it in, TDR will still protect them. Some of the functions like host containment, their host may be contained, they won't get it unlocked until they get back on the network and it communicates out. But if they're already offline, they won't even notice that they're already offline. We strive for everything to be automatically remediated. So we don't want you to have to manage your anti-malware solution other than the initial setup. So we really have policies in place out of the box that are some general best practices, and then a lot of tuning capabilities, very flexible rules that you can set to allow you to set policies and actions that are tailored to your exact network needs. Of course, you can also always go in and manually quarantine a file or manually contain a machine or manually execute a registry delete. But primarily, we design this around automation. And then finally, coming in 12.6 and 12.5.4 for older devices very, very soon in the next month or so, we will have TDR enforcement on the Firebox. So this will be a key that you can turn on the Firebox that will require any device connecting to it to have TDR running before it will build that VPN connection. So making sure that your mobile devices are safe and secure and not bringing an infection into your network. One last note, you may have seen WatchGuard is acquiring Panda Security. So Panda is a best of breed antivirus and EDR vendor. They bring to the table tons of fantastic threat intelligence and software that we will be using to enhance our endpoint security platform over the next year and more. So more to come on that. And finally, since we all have so much time at home now, go check out our daily security bites and the 443 podcast to learn more about emerging threats and how to protect against them. Some really interesting information that our security research team, Corey and Mark and folks do, that they publish some fun and really informative videos and podcasts that can help you keep in mind what you need to be looking out for. We also have our blog, Secplicity, and of course, we're on LinkedIn, Twitter, Facebook. To learn more about any of the tools that we talked about today, our firewall help is very, very complete and easy to browse. For our partners, we have the WatchGuard Learning Center available to you. You can go in and watch on-demand video content or sign up for instructor-led training to learn more about how to use our tools. And that's all I have for today. Thank you for joining. I'm going to stop the recording now. We'll stay on if anyone has any additional questions. Thank you.